Hi everybody. Today I would like to speak a little bit about derivatives and the initial concepts and ideas behind it, which might be very helpful as you study further this subject. So derivatives. The first idea I would like to relate to derivative is that it is something that happens at a given point. So it's the instant rate of change. It's how something is changing on that very moment, not as an average or not during a period of time. It's just on that very instant, and that's what the derivative tells us. And the second idea is the idea of the slope of a tangent line to a function, let's say. And this is a graphical approach, and actually we'll see that the slope itself is the derivative of a function. Let's make a quick sketch here just to visualize what I just said. For any given function f of x, if we want to know the rate of change at this specific point, then we need to determine the tangent line to this point, and the slope of this line will tell us the instant rate of change. So for each point we'll have different slope of the tangent line, so we'll have infinite tangent lines, and we can then determine the derivative. First we need to recap slope from algebra. So if you have a line, how can you determine the slope of this line? Well, you basically pick up any 2 points of this line, x1, x2, y1, y2, and we know that this delta y, so the change in y divided by the change in x, equals the slope. So slope is delta y divided by delta x, y2 minus y1 divided by x2 minus x1. If we have any given function, so let's draw a random function here, f of x, and we wish to determine the derivative in this point. So what we're saying is we want to determine the tangent line in this point. How can we determine the slope of this tangent line? Well, what we need to do is we can pick the secant line to this function. So let's say, so there is the secant line here, and in this point we have x, and the other point where it crosses is, let's say, x plus h, being this distance here, h. And these 2 points in the y-axis will be f of x and f of x plus h. Okay, and the idea is to bring this point here closer and closer to this first point here. So as we bring it closer, we see that the secant line will approach this white line, which is the tangent line, and we'll just erase it here. So we will have to find a limit where this point x plus h moves towards x, and this point moves towards f of x, and then h will be smaller and smaller and smaller until its h is 0, and we have the tangent line. Sorry. So let's write down the expression for the slope. So from what we saw here before, we'll have that the slope of the secant line equals delta y. In this case will be this one here, delta y, and this will be delta x. So delta x y. So the change in y divided by the change in x. In this case it will be f of x plus h minus f of x divided by x plus h minus x, which is h. It's just h here. So we want to bring this point here to this point, so we want to make h goes down until 0. So we will then define this as the slope of the tangent line, and we'll say that the slope of tangent line we will call f prime of x, and that's how we determine it, and it's the slope, I'll write it here, it's the slope of the tangent line, so the slope of tangent line to f of x, and it will be defined as the limit when h goes to 0. So when h goes to 0 of this expression here, f of x plus h minus f of x divided by h. And this is how we define the derivative. So this is the slope of the tangent line in the f of x. And it's a little bit abstract, so we'll do an example here for us to better understand. So, example given. If you have f of x, x squared, what's the derivative when x is 1? So it's asking us what's the slope of a tangent line when the function f of x has x equals 1. So let's calculate it by the definition. So by this definition we'll 1 and 0.1, so f prime of 1 equals limit when h goes to 0 of f of h minus f of 1 divided by h, which will be limit, so f 1 plus h, and the function is x squared, we will have 1 plus h squared minus 1 squared divided by h, which will be 1 plus 2h plus h squared minus 1 divided by h, and this 1 equals h times 2 plus h divided by h. And then we have that f prime of 1 equals the limit when h goes to 0 of 2 plus h, which is 2. And this tells that the slope for the tangent line is 2. The tangent line for this function here when x equals 1. So if we draw, let's draw it here, y and x, and we have the function x squared. So when x is 1, we know that y is 1 because f of x is equal squared, and the slope, no, not white, so the slope of this line in this point here, so the slope of tangent line equals 2. Well, that's it for now. Thank you for watching.